Okay, I received the following question from a student, and they were having a little bit of difficulty simplifying this equation. So let me write it out here, and I am going to click pause while I do so. Okay, I'm back with you. Okay, so let's look at the 3 steps that I indicate that I would like you guys to use when solving equations. Step 1 is to simplify. We're going to simplify both sides of the equation as far as we can go. And then in step 2, let me use a different color, we're going to use opposite operations to quote-unquote move things from one side of the equation to the other. And then step 3, we're going to repeat steps 1 and 2. Okay, so on the left side of this equation, over here, we are going to look at the fact that we have, well, my pointer's not working, there we go. We're going to look at the fact that we have brackets here and parentheses in here as well, right? Because of our order of operations, when we're simplifying expressions, and what we have on the left here is an expression, is that we are to get rid of all of our groupings first, the P and PEMDAS. And just to remind you of what that is, oops, give me my pen. Please excuse my dear Aunt Sally. So the groupings, the P stands for parentheses and brackets and anything else that are grouped together. So the first area where we have grouping is here. We have brackets. So we have to follow the order of operations inside here. And we notice we have parentheses. So we have to look here. Can we do anything with this y plus 4? No, we cannot, because they are different terms. So we have to get rid of these parentheses somehow, and that's to use the distributive property. So when we do that, we're going to write down the things we don't change. So I'm not touching the 15 or any of this stuff, right? We're going to go through this process until we get to the point where we're going to change something. Because we have a negative 4 times this y plus 4, the sum of this y plus 4, right? So we have this negative 4 times this big number. We don't know what that number is because we don't know what y is. So in order to get rid of it, we have to use that distributive property that I showed everyone in class. And I will write it down here just momentarily. I'll erase it here in a moment also, but just so you can be reminded that when we have parentheses, if we want to get rid of it, we have to distribute. So we take the A times the B, and we're going to add it to the A times the C. Remember my story about the Walmart circular being delivered to every house in the neighborhood, right? Okay, so now I'm going to erase that so that it doesn't run into my equation later. My stylus is not working, you guys. I might have to get me another one. It is not picking up my stylus very well. Okay, so since we're going to distribute this negative 4, we'll have a negative 4 times y. So we'll write a negative 4y. And then we're going to take this negative 4 times this 4 out here. Wish this stylus would work. There we go. I'm going to take that times that one. So a negative times a positive is a negative, so we get a negative 16. So we've simplified a little bit, but we're not done, right? Because we still have things that we can put together on the left. Notice we're still inside the brackets, still inside that grouping, so we're still in the P position, right? So we're going to work on simplifying this region now. This is the region that we're working on now. All right, nothing is working on my app today. I do apologize. My undo button's not working. Okay, anyway. I don't know why this is not working. Might be a glitch in the app. Okay, so since that's what we're going to simplify, let's do that now. So I'm going to bring down this 15 because we're not changing the 15. And we want to get rid of this parentheses. So although we don't see a 1 here, we can treat this negative as if it were a negative 1 right there, right? So it's kind of what we're doing. Anytime we get rid of parentheses, and there's a negative in front. The rule is just to change all the signs inside the parentheses when you get rid of it. Because when you take this negative times this positive 3, what you get is a negative 3, right? This would be easier if my pen would work. There we go. A negative 3. If we take this negative times this 7y, what we get is a negative 7y. Notice how all the signs are changing? We get a negative times a negative, we're going to get a positive 4y. And then this negative 16 times a negative gives us a positive 16. So now our process is starting to look better. It's looking prettier than it did in the very first step, right? So in the next step, we're going to combine our like terms. We're still on step 1, simplifying this side over here. So we're looking for, this is a constant, right? This 15 is a constant. So we're looking for any other constants that we see. Well, I see one here, and I see one here, right? So 15 minus 3, well, that is 12. And then we're going to add 16 to it, because there's a plus in front of that 16, right? So we're going to add a 16 to it. So that gives us 28. So you can kind of just gently cross through the ones that you've used already. That way you don't forget to use them, and you know you've used everything by the time you get to the end, right? And then the next step here, we have this y term, so we're looking for any other terms that have just a y in it, and we have one here. So we have a negative 7y plus 4y, which gives us a negative 3y. So that is as far as we can go on the left-hand side. So now we have to simplify the right-hand side. So again, we're going to follow the order of operations, so we have to look for our parentheses. So I have a set of parentheses here, and I have some brackets here, and then inside those brackets I have parentheses. So that's where I'm going to be focused first, is in here, this inside set of parentheses that's in those brackets. Okay, I just really wish my undo button would work. It's not working. Okay. Anyway, so I'm trying to clean this up a little bit. All right. So since we're not changing this information out here, I'm going to keep the yellow pen. It seems to show up a little bit better. We're going to get a negative 3. Come on, right? Let me see if I can find another stylus. I'm sorry, I'm going to pause this for a moment. Okay, let's see if this one works better. I think it might. Okay, so we're going to get rid of these parentheses. And again, we can't combine, these two terms, right? Because they're different. We have a y and a constant. We have a variable term and a constant term. So therefore, we need to, again, use the distributive property, because if you notice, we have this number out here on the side that is being multiplied by this difference, right? Which is another way of writing a sum. But anyway, let's get rid of that there. And then also notice out here in the front, we could do that here as well, because this set of parentheses is separate from the other brackets. So we're going to use the distributive property in 2 places, there and here. So we're going to take this negative 3 times 2y, which is going to give us a negative 6y. And then a negative 3 times a negative 7 is a positive 21. All right. I'm going to leave this minus sign. I'm going to leave this bracket, right, because we're not touching that yet. We have to follow the order operations. And we're going to get 5y minus 5 minus 1y. I'm just going to write y plus 12. And we're going to close our bracket. Okay, so now, again, we're still following the order operations, and we have to get rid of the brackets. So what we end up with is a negative 6y plus 21. And remember, every sign is going to change in here because we're distributing this negative sign into each one of these terms. Here, 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 and here. Okay. So since we're distributing to each one of those, that positive 5y is now a minus 5y when the brackets are gone. This is a plus 5. This is a plus y minus 12. All right. So now I see here, following order of operations, right? There's no exponents, no more multiplication going on or division. So we're looking at addition and subtraction here. So when we're adding and subtracting, we're looking for like terms. This is all still step one of solving equations, simplifying, right? We have this negative 6y, and we're looking for any more y terms that are in our expression on the right. There is a y term here and here. So a negative 6y minus 5y is a negative 11y, but then we're going to add a 1y to that. So that gives us a negative 10y. So remember, as you use these items, let's slightly cross through them. You don't want to cross through them too dark, because if you make a mistake, you want to see what was there before if you're trying to correct your mistakes, right? And then we have this 21 plus 5, so we're at 26. And then we're going to subtract 12. So 26 minus 12, it looks like it's going to put us at 14. So step one is now done. We have simplified both sides as far as we can go. So remember, the purpose that I mentioned in class is for us to isolate the variable on one side of the equation all by itself. So that means we've got to combine terms, and if terms aren't together that are alike, we've got to move things from one side of the equation to the other. For example, since I'm trying to get to my variable, I have some y's over here, but I also have some y's over here. So I need them on the same side of the equal sign. Also, I need to put my numbers together, right? Those need to go together as well, because what's going to happen is if I have a variable on one side, then all the numbers are going to be on the other side. So I'm going to add 10y to both sides. And when I do that, this gives me the following. Looks like this. Because adding 10y to both sides is actually going to eliminate the y's on the right-hand side, because that is my opposite operation of a negative 10y. The opposite of a negative 10y is a positive 10y, right? So when we've done step two, we've used opposite operations to quote unquote move things. So now we're at step three. We're going to repeat step one, which is to simplify. So we're going to combine these like terms on the left, which gives us 28 plus 7y. And we are going to combine our like terms on the right. So a negative 10y and a positive 10y, those are opposites, which gives us 0. And 0 plus 14 is 14. Now let's see if I can move this up without causing too much confusion. I thought that's what was going to happen. Let's see. Apparently you got to move it in sections. Just need a little bit of room. All right. Okay, so now I have some y's on one side, but I don't have all the numbers, so I'm going to have to subtract 28 from both sides of my equation. And when I do that, because my 28 is positive, right, so the opposite of that is to subtract 28. Sorry, this new stylus now is too hard, I guess. So it's taking a while to write. So we're going to simplify again. So we end up with 7y on the left. And when we simplify on the right, we get a negative 14. And so I'm going to use a new slide. Excuse me. Here we go. We have remaining 7y equaled a negative 14. That's what we had when we simplified on the other side, right? So what we're going to do is the opposite, because 7 is being multiplied by y, and we want y by itself, so we need to divide y by 7. So since we're dividing by 7 on that side, we have to do the same on the other. And a number divided by itself goes to 1. So 1 times y is still y. And then we have on this side, when we simplify, on the right side, when we simplify, we get a negative 2. So we have found our y because we have obtained the purpose. We've reached our goal of getting the variable on one side by itself, right? So therefore, the answer is y equals a negative 2. And you can check yourself. Sorry, I picked the wrong color, but you get the idea. And you can always check yourself by plugging a negative 2 back into the original equation and making sure that you get the same number on both sides, which results in a true statement. If you do not get a true statement, you know you did something wrong. So I hope this information has helped you. If you have any questions, please feel free to contact me, and have a great evening.